Welcome to The Explainer. Today, we're going to dive into a really fascinating story from the trenches. It's about the team at Microsoft building an AI agent to manage Azure, and the completely counterintuitive lessons they learned about how to make AI actually work reliably in the real world.
So check this out. It's a bit of a paradox, right? How did massively simplifying their system, throwing out almost everything they built, actually make it better? Well, it turns out the secret wasn't a bigger, fancier model. It was a total shift in how they thought about feeding it information.
You have to understand, the team's goal here was huge. They wanted to create an AI agent that could handle production incidents for Azure. We're talking about a system where a few seconds of downtime can have massive consequences. So reliability wasn't just a nice to have, it was literally everything. And, they did what you'd expect. They tried bigger models, they polished their prompts, but the big jumps in reliability, they just weren't coming from that. The real breakthrough came when they started mastering what information they fed into the model's context window, when they fed it, and in what form. They called it context engineering. Okay, so to really get this, we've got to go back to the beginning. Let's look at their first strategy, which was basically trying to control the model with an iron fist. And, spoiler alert, it led them straight into a dead end.
So they started from a place of mistrust, right? They didn't really trust the model's reasoning, so their reaction was to constrain it. Every little action the AI could possibly take got its own tiny specific tool, and within just 2 weeks, they had over 100 of them. The system prompt became this giant policy manual. It just spiraled out of control.
And that led them to their first big aha moment. They realized they hadn't actually built an intelligent agent at all. What they'd built was a really fragile, rule-based system. It was like a house of cards, great for the exact scenarios they'd planned for, but it just collapsed the second it saw something new.
So that realization triggered a complete 180. They basically threw that whole approach in the trash. Instead of trying to constrain the model, they decided to do the opposite. They decided to empower it. And this led to their first huge breakthrough.
The shift was radical. They asked themselves, what if instead of 100 tiny specific tools, we just gave the agent a couple of really wide ones? So they gave it direct access to the Azure command line, AZ, and the Kubernetes command line, kube control. And boom, they instantly unlocked the entire power of those ecosystems. And here's why that worked so well. You gotta remember, these large language models are already trained on mountains of data about tools like AZ and kubectl. They know how to use them. By hiding these tools behind their own narrow ones, the team was actively fighting the model's built-in knowledge. Giving it direct access meant they could finally lean on that knowledge instead. Okay, so they're feeling pretty good at this point. They've had a big win, so naturally they tried to scale up. They thought, hey, let's organize our AI agents like we organize our human teams, with specialists. But they quickly learned that what works for humans doesn't always work for AI.
Now, on paper, the theory was beautiful. You'd have an orchestrator agent that gets a query, and it figures out which of the 50-plus specialized agents to send it to, the networking agent, the storage agent, and so on. This kept each agent's job simple and its context lean. At a small scale, it worked great. What could go wrong?
Well, in production, that clean theory completely fell apart. The system just got plagued with all these weird problems. Agents would get lost and couldn't figure out who to talk to. A single badly written prompt for one agent could break the entire chain. They'd get stuck in these infinite loops, just passing the task back and forth. And they developed tunnel vision, totally missing obvious problems just because it wasn't in their narrow little domain. The lesson here was so clear, and it was the exact same lesson they learned with the tools. They were spending their precious context budget on all this overhead, just coordinating between agents, instead of giving the agents the power to actually solve the problem. It was the same fundamental mistake, just one layer up.
So what did they do? They took that beautiful, complex hierarchy of 50-plus specialists, and they just flattened it. They collapsed the whole thing down to just a handful of powerful generalist agents, and they armed each one with those wide, capable tools from before. And guess what? Reliability shot right back up.
All right, so they've simplified their tools and they've simplified their agents. Now the team turned its attention to the final piece of the puzzle, mastering the flow of information into the model's context window in the first place.
And this led them to tackle what was their single biggest source of failures, trying to get the AI to analyze huge amounts of data. Their first approach was probably what you or I would do. Just dump a giant table of performance metrics into the prompt and say, hey, find the weird stuff.
But this was just fundamentally the wrong way to do it. It's like asking a poet to do your taxes. You're asking a probabilistic system to do deterministic math. The solution, which seems so obvious in hindsight, was to stop sending the model the data. Instead, they sent the data to a code interpreter and asked the model to write the Python code to analyze it.
And this insight was a total game changer. Use the LLM to decide what to compute, but let actual, code do the heavy lifting. Let the LLM be the conductor, not the entire orchestra. After they made this one change, their biggest source of errors just dropped to zero. Gone.
And they didn't stop there. They came up with all these other really clever ways to stretch the context window. They externalized the agent's plan into a simple to-do list so it didn't have to keep it in its head. They started summarizing past conversations. And this one's brilliant. They started treating large outputs from tools like files, so the model could query and filter them instead of having the whole thing dumped raw into its context. So smart.
So after all these months of trial and error and these huge breakthroughs, the team stepped back and realized there was this powerful, unifying principle that tied all of these lessons together.
They realized they weren't just building an SRE agent anymore. They were practicing a whole new discipline: context engineering. It's this art of treating the context window not as some infinite bucket you can just throw stuff into, but as the most valuable and sensitive resource in the entire system.
And this analogy from Andrej Karpathy just absolutely nails it. See, as you fill up a model's context, its performance doesn't just get a little worse, it can literally fall off a cliff. More tokens don't just add a bit of latency, they quietly eat away at the model's accuracy.
So at the end of the day, well, yeah, better models are always going to be important. The thing that you can actually control, the thing that really moves the needle on reliability, is this disciplined management of context. It's all about giving the model high-quality, high-signal information to work with, quality over quantity.
And this whole story leaves us with a really fascinating question to chew on, right? Is the path to more capable, more reliable AI not just about building bigger and bigger models, but about getting much, much smarter about how we manage their memory?